why not just start with the knowledge graph instead of the UNS? And or can a knowledge graph just be the UNS and replace the UNS? Take 0. All right, so in our What is Digital Transformation 2026 video, there was a comment by, I think it's Walid Mata. He asked the question, why not start with a knowledge graph instead of a UNS? And it's actually a pretty common question. Actually, a really common question I get is, what is the difference between a knowledge graph and a unified namespace? So I'm actually going to go through that. And then I'm going to do a demo, and I'm going to show how they work together, okay? But let's start with, if I'm going to answer the question, can a knowledge graph replace a unified namespace? The answer is certainly not yet. Maybe in some scenarios, the knowledge graph could be a UNS, I think. I've never done it. I have yet to get to the point where the single source of truth, semantically organized, real-time current state in two-dimensional relationship isn't needed. I haven't gotten to that point. I just haven't seen it. I'm not even sure we're going to get there. So the answer to the question is not just an absolute no. It's based on, all of my projects, I'm using UNS and knowledge graphs together. And I'm using them for different reasons. There isn't really an overlap, with the exception of the 2D relationship is kind of the starting point for the knowledge graph, and then the knowledge graph extends. There are things about unified namespace knowledge graph can't replace. Their knowledge graphs aren't designed to replace certain things about unified namespace. There are attributes and characteristics of UNS that knowledge graphs just don't have. All right. So we'll start, what is unified namespace? Just, our baseline. So it's the structure of our business and all the events at its base level. It's the business semantically organized. Okay. It is current state. So it is the single source of truth for current state. Whenever I'm looking at a unified namespace, I am looking at the state of the business right now. A knowledge graph is the structure of business and knowledge, not just right now, but over time. Okay. So UNS is current state, semantically organized. There's a structure, two-dimensional, parents, children, siblings. That's it. Think file share. UNS is structure and state. Okay. What's a knowledge graph? And so this is actually an email response that I sent to a client who asked this question. I broke it down into what is a graph, what is a knowledge graph, and then how do UNS and knowledge graph work together. So a graph is a data structure made up of two things. Okay. So nodes, entities, a thing, and then edges, relationships, how two things connect to one another. Okay. Two or more things. That's it. There isn't a required hierarchy in a knowledge graph. A knowledge graph could just be two nodes with a single relationship between the two of them. That's a graph. There's no required direction in a graph. Okay. Any node can connect to any other node. It can have any number of connections. All right. That's the key contrast with unified namespace. Your unified namespace is a hierarchy. It is the structure of the actual business. Enterprise site, area line cell, we use ISA 95 Part 2 as the predominant way that we structure unified namespace, right? A graph doesn't have that constraint. Okay. So a pump can connect directly to a work order, or a work order directly to a customer, or a customer to a shipment. Nodes connect to whatever they actually relate to, not just to what's above or below them in an organizational structure. Now, one of the things I was thinking about prepping this video is there's the answer to this question. I could literally shoot 20 videos answering this question, and I could just focus on simple things, like, for example, visualization. And that's actually part of what I'm going to do here. One of the powers of unified namespace, you can use a unified namespace to use indirection so that I can build a visualization that is designed for any type interface based on a level of the hierarchy. So I can say I've got line 1, line 2, line 3, and they're in area A. Okay. I can create a visualization that gives me the ability to point to line 1, line 2, line 3. I can use a pointer. Okay. And so what will happen is when I go line 1, it's going to be enterprise site area plus line 1. That's the indirection. And then all I have to do is change it to plus line 2. And the visualization will render the data that's at that location. So Unified Namespace is really powerful in that capacity. Another way that Unified Namespace is really, really powerful is there are contextual relationships baked in to Unified Namespace. So for example, there is a relationship between a pump and a work order if both a pump and a work order are in a Unified Namespace. Like I can see the value of the flow coming out of a pump and the value of the work order at the same time in context to one another. Unfortunately, there's no meaning to the context. That's where a knowledge graph comes in. Okay. All right. So what is a knowledge graph though? So if a graph is a data structure made up of two things, nodes and edges, okay, what's the knowledge graph? Well, a knowledge graph is a graph where the nodes and the edges carry meaning. Not just these two things are connected, but what kind of relationship it is. And the most common one, knowledge graph in industry, is going to be feeds. So this node feeds that node. All right, that's a really popular one. So not just pump 7 and line 3 are related, but pump 7 feeds line 3. Motor 12 drives pump 7. Line 3 is downstream of furnace 2. Order 4471 was produced on line 3. So the way to understand Unified Namespace and knowledge graph is this. A UNS organizes where data lives and gets it moving in real time, normalized and contextualized to one another. And then it serves a whole other host of features. But UNS gives you current state, contextualized and normalized, organized like the business. That's what Unified Namespace does. A knowledge graph organizes how things relate to each other, regardless of where they sit in that namespace. So there are relationships native to the UNS, but a knowledge graph allows you to extend those relationships into three-dimensional relationships, right? So we're no longer just related to things above and below us directly or things parallel to us, our siblings. We can be related to something on the other side of the business. And we just draw essentially a dashed line, which we call our user edge, between this node and that node. Why do they matter? Like at the end of the day, why do I need a unified namespace and knowledge graphs? Like again, I just don't see a scenario where knowledge graphs replace unified namespace. I was having this conversation about i3x the other day. I think one of the real powers of i3x, the API, is in driving knowledge graphs, actually. That's it, at the end of the day. That's where I think it's real value. Interoperability obviously is super powerful with i3x, but it's really in driving knowledge graphs is where I think i3x is going to become really powerful. And the reason knowledge graphs are important is because digital transformation is all about converting data into decisions, not just for humans, but also for agents, right? And human beings can, on the fly, deduce a three-dimensional relationship between two unrelated nodes. Agents do the same thing, except agents need a knowledge graph to traverse in order to be able to do that. Okay, it's a separate video. I'm not going to get into that piece there. But why do they matter? Well, the answer is because if the promise of digital transformation is really about doing more with less, increasing productivity, increasing efficiency, being better for the environment, better for our communities. If that's the goal, then what we have to do is make better decisions. And the best way to make better decisions is to do data-driven decision-making. And the best way to get the most out of data-driven decision-making is to use hierarchy and current state in conjunction with three-dimensional relationships and graph what we learn over time. They work together. That's why they matter. How do they work together? All right, so this is another email I sent where I just basically said 2D and 3D relationships together turn data into decisions. Well, like right now, Flow Software is coming out with Atlas. So Atlas is essentially, well, there's really nothing like it on the market. But Atlas is essentially the tool that's going to give us the ability to build knowledge graphs in a way that nothing other than like Palantir gives us the ability to do. I would say that the Atlas offering coming from Flow, by the way, shout out, thank you for sponsoring this video. The promise of Atlas is to realize the promise of two-dimensional and three-dimensional relationships together to drive data to decisions in a way where I can exercise powerful data governance over those actions. Right now, what's really missing in the knowledge graph world, not in the UNS world, but in the knowledge graph world, is hardcore data governance. Okay, that is, managing change in those relationships. Taking a relationship I've already created and recreating it in many places. Think class structure, class and instance structure. All right, what I want to do is I want to kind of show at a high level how this works. We're going to use Steelco, our Steelco plant, as our example here. All right, so if you remember, I've gone over this a bunch of times, but essentially we have a rolling mill. We basically take scrap, okay? We take scrap from our scrap yard, we melt it down, we create billets, we let them cool, we reheat them in a reheat furnace, and we run through a mini mill and we make rebar. In this case of this plant, we make rebar. Right now, we're just going to focus on our melt shop. I'm going to show you the relationship between unified namespace and knowledge graph and kind of how this works, all right? And in fact, to you folks at Flow, when I implement Atlas for the very first time, I'm actually going to do it in this plant here, okay? So first thing I want to do is I want to walk through the process flow, and then I want to take you through the unified namespace, take you through knowledge graph. So we essentially have a scrap yard, okay, where trucks show up with scrap steel, okay? They arrive at the plant gate, and they queue for the scale. We get 8 to 10 truckloads of steel per shift, and they get dumped in a yard, okay? The only context we get when they deliver the steel is basically we store in an inventory database, hey, we got a load of this type of steel, and it's out in the yard. Then we get work orders to produce billets, and the customer is the rolling mill that's going to use those billets. So what happens is we have a big overhead crane that we have some cranes out in the scrapyard. They're magnetic cranes that basically pick up the steel, and they dump them in a spot where this overhead crane is going to be able to pick up that steel and fill up the electric arc furnace. All right, they take that scrap steel and they drop it into the electric arc furnace. Our electric arc furnace has a PLC, and then we have the arc furnace database. Okay, we have a charge that runs. Okay, and that charge that runs is basically, let's say, 40 minutes to 90 minutes to melt the steel and get the metallurgy right. Okay. There are some offline tests that are done here, and then you basically dump the arc furnace into the ladle, and then the ladle comes over, and while it's suspended, we do our chemistry tests. Okay, we make sure our metallurgy is right. If the metallurgy isn't correct, we might add some carbon, we might add in some alloy. There's some things we might add into it to get the recipe right, and then essentially the ladle goes to the ton dish. The ton dish dumps into a triple strand continuous caster, and that continuous caster produces 3 40-something foot billets. We basically have a torch that cuts them at 40-something feet, and then they go into the shipping yard where they cool down. All right. So I've got database, PLC, database. In chemistry, I've got a PLC plus the LIMS database, and in the continuous caster, I've got a PLC. When we build our unified namespace, we essentially, let me zoom in here. We connect to our PLC, we connect to our database, we install our IIoT platform, and essentially we ask ourselves, how is the business organized? And we organize the business in a UNS, and then we drop in our PLC data, we connect our PLC, we bring in the raw data points from the PLC, and then we abstract from the database and the PLC data to create a UNS that gives us current state. So we have our bath temperature of the furnace, we have the energy consumption of the furnace, we have the heat number, we have the heat phase, which phase we're in right now, we're tapping, we have the weight of the heat, and then we have our tap weight coming from the PLC. Okay. Inside the PLC, we've got our raw cooling water values, we have our current values, we have our electrode position, we have all of the data that is for the arc furnace in our arc furnace namespace, in our unified namespace. Okay. We use this to develop Visualization. So this is a live operator overview of the furnace. So we have the overview. We have so which heat number, heat weight, all the things that we see on the screen are coming from the unified namespace, and what we're looking at is real time. Okay, I can see electrical, I can see thermal, I can see cooling and off gas. All right, here's a more comprehensive overview where this is a arc furnace HMI that is using every single data point in this unified namespace. So everything under arc furnace, every single value is included on this visualization here. This visualization is driven from the UNS. When I click on roof temp, I am looking at the values that are inside the unified namespace. All right. And what I'm going to do is, rather than diving, I didn't do visualizations for all of the processes, but what I did do was I broke out the unified namespaces. So here we have our ARC unified namespace, and here we have our ladle metallurgy. So you notice Steel Co, Dallas Melt Shop, they are related to one another. The two-dimensional relationship is the same. Here we only see ladle metallurgy. So we have our chemistry, carbon, grade target, manganese, phosphorus, silicon, sulfur, okay, and then we have our raw PLC data. All right, if I go down to the continuous caster, same situation. So these are the billets that are being generated, how many's been produced this heat, and then we have our raw PLC data. All right, when we build a unified namespace, that's what we're doing. We're going through the value stream, we're looking at the data sources, we're bringing the data sources together, we're organizing the business, okay? And then what we end up with is something that kind of looks like this. If I take the melt shop and the rolling mill and the business intelligence applications and then the stuff that comes from ERP and I put them all together, then what I end up with, in this case, we have our melt shop completely unified namespace. So the arc furnace, the billet warehouse where it comes out of the continuous caster, a separate EAF namespace for OEE, our ladle metallurgy, what we just saw over there, our continuous caster. What we've done is, as we've moved up the business, we have created a more comprehensive unified namespace. All right. One of the things I want to show you is these visualizations here are essentially how operators do their job. This is how they control the process when the process is doing what it normally does. Okay, this is the supervisor monitoring the process when the process is doing what it normally does. This is maintenance monitoring the process when the process is doing what it normally does. Okay, so these two visualizations are driven from the unified namespace. The unified namespace manifests these visualizations, which is the interface through which human beings interact. All right, now what I'm going to do is I'm going to show you, I want to do two things first. Number one, I want to show you the unified namespace for the melt shop, okay? Which we've looked at above. And what does that look like in a knowledge graph? So what we've done, what I've started with, this is a graph of the unified namespace, but it's not the knowledge graph of the melt shop, okay? So we have nodes and we have relationships, but we don't have what type of relationship it is, okay? Well, first thing that we're going to do is we're going to take the unified namespace and we're going to use an agent to speed this up. But the first thing I want to do is I want to create some of these three-dimensional relationships. All right, so the first thing that I'm going to do is I'm going to ask the agent to create those three-dimensional relationships for me. All right, so I'm asking it to analyze the Steel Co melt shop. I want you to identify the relationships that are true about the physical process, but are not visible from the topic hierarchy alone. Okay, the agent's doing the analysis, and it is going to draw the relationships here. All right, and I'm gonna explain the relationships here in a second. All right, so let's start by pulling the correlate knowledge graph. It has no user edge. What I've done is I've drawn 5 relationships the tree structurally can't carry. These are three-dimensional relationships only. So, for example, the furnace feeds ladle, and the ladle feeds the caster via the tundish. So real material flow, but arc furnace, ladle metallurgy, and continuous caster are three unrelated topic level branches with no naming clue that molten steel physically moves between them in that order. So we've added furnace feeds ladle and ladle feeds the caster via the tundish. So we have furnace feeds tundish right there. And we have feeds tap steel, and we have gates quality hold. Perfect. All right. So we've added in our three-dimensional relationships. We added in caster feeds the billet warehouse. We've added in arc furnace and electric arc furnace and OEE are the same physical asset. And chemistry approval gates the casting. Okay? All right. So what we've done is we've added in, now we have a knowledge graph. Okay? So we had a graph from our unified namespace, and now we are applying knowledge on top of that graph, and to create a knowledge graph. And right now we're only doing it in the melt shop. Okay? All right, so the next thing that we're going to do is I'm going to say, the first thing I want to do, the first obvious thing I want to do to turn data into decisions is I want to ask my agent to help me, or a human being could do this too, but the agent just makes it faster. Okay? I'm going to ask the agent to build a report for me. So I want you to build an operational status report for the melt shop by analyzing its knowledge graph together with the live process data. So what we're doing right now, we're taking the current state from our process from UNS, and we are asking the agent to apply the knowledge to it in order to do an operational status report. All right, so that's what the agent is building right now. Okay, so it's pulled data from the unified namespace, but it's also looked at the relationships. And now what it's going to do is it's going to reason through those relationships using both current state and knowledge. Okay? Combine them together to reason to a specific outcome. All right. So let's go ahead and read our report just real quick. Okay? So operational status report. The melt shop is currently mid-changeover between heats. Heat 540 has already been cast, and it's in the cooling stage in the billet warehouse. It's giving us current state, and now it's saying, okay, here are my findings by relationship. Okay? So the tap weight, so both endpoints read 0 because the heat 54 is still in the charging phase. What it's doing, what this report is doing, is it is showing us that the agent understands the relationship between the arc furnace and the ladle metallurgy. So the arc furnace is where we melt the molten steel. The ladle metallurgy is basically the ladle plus chemistry together. It shows it understands that relationship, and it's giving us the conditions of that relationship. All right, here's the last thing I want to do. Now what I want to do is I want to ask the agent to build me a whole new visualization. What we've done is we built visualizations here. These are from the UNS, and these are, standard ISA 101 visualizations that are using ISA 95 Part 2 structure to navigate them, right? These are obviously very powerful. They're beautiful visualizations, and they're useful to operators. But one of the things I want to show, we can use a knowledge graph to build a better visualization, okay? So we can build a visualization that applies these relationships, okay? So what we're going to do is we're going to copy this, and we're going to end up with a fresh visualization that's going to extend from this knowledge graph. So we'll go over here. And what we'll do, we'll go ahead and connect this, because this new visualization is going to apply the knowledge we have in our graph to redefine how the visualization looks. Okay, so basically what's happening right now is there's a MCP server that is connected to UNS Studio. So if you look here, we have UNS Studio. UNS Studio is running over here. So UNS Studio is running here. Okay, we're running our Steel Co simulations, and we have dashboards in here. Normally, you have the ability to build, you can build the visualizations inside of UNS Studio, but there's also an MCP server that allows external agents to build visualizations inside the platform. And so right now it is building the dashboard inside of UNS Studio. And then this is our new visualization. Okay. So now what we've done is we've built a visualization that is applying the knowledge. Okay. So this is a layout that's generated from the knowledge graph relationship. So this is giving us the ability to take the current state that we have inside of UNS, but then visualize it based on the upstream, downstream relationships or business relationships. And this is a very simple example, but what we're showing here is arc furnace feeds ladle metallurgy. We're showing the relationship between the two in this visualization. All right. So the reality is that the big piece for knowledge graphs is all about taking knowledge, applying it to real-time data, and making better decisions. At the end of the day, that's what we're doing. That's what knowledge graphs are for. Knowledge graphs are all about creating three-dimensional relationships that help us make better decisions. Knowledge graphs are also the scaffold that agents traverse. They navigate through those relationships to get to the location where they look back at current state for the data that they're going to analyze, right? You know, obviously large language models are context limited. So what we want to do is give it a scaffold, give agents a scaffold to navigate in order to get to the data and information that you want the agent to use to make its recommendations to you. All right, so the question is, why not just start with the KG, right? Well, the answer is because the best way to start a knowledge graph is with a unified namespace. They are symbiotic. And you know, I brought up Atlas earlier. Atlas is a tool we are going to use to extend unified namespace to apply this knowledge, just like I do it in Notice, just like I do it in UNS Studio. The reason this question comes up over and over and over again, why not a knowledge graph instead of a unified namespace, is because people don't understand how they work together. You know, and we've barely scratched the surface with the capabilities of knowledge graphs. I will say this piece here. The idea that LLM-driven agents are going to be world-class decision makers absent the guidance and input of human beings it's pretty preposterous. I mean, anybody who works with agents understands that an agent is pretty useless without human beings. And human beings can't be super people without agents. And unified namespace is how human beings view structure. It's why it's so popular. Okay. Human beings struggle to see relationships in knowledge graphs, but agents don't. Okay. That's part of the symbiosis. You know, UNS is how human beings view things. And knowledge graphs are how we can apply knowledge to the way that we view things, okay, additional knowledge, and we can create the scaffold through which agents navigate. So, no, can't start. I mean, you don't start with the knowledge graph and then build the UNS. You start with the UNS and then you build the knowledge graph. And you want the underlying structure of the knowledge graph to extend from the structure of the UNS. So as the UNS grows, so does the knowledge graph. All right, hopefully that helps. Like, subscribe, comment down below, and I'll see you in the next one.